Hello dear student, welcome to GDC and welcome to Pharma Thunderstorm series, in which I will discuss today with the colligative property, few tricks I will tell, there is a new concept, some question for the practice for this topic only. So dear student, this test series is specially designed for the all pharma competitive exam, either it's your GPAT, NIPER, drug inspector, pharmacist. So here I am Ankit Sani, I am dealing today with the colligative property. So first question arises, what is colligative property and what is its definition? So uh, colligative property are the property which depend only on the number of solute particle but not on the nature of solute particle, and the colligative property is inversely proportional to the mass of the solute. So here you can I hope you know like what is mole. I hope you know mole. So mole is equal to gram of solute. Mole is gram of solute divided by molecular mass, molar mass. So colligative property is somehow inversely proportional to the molar mass. And most important point that you have to note here, that it doesn't depend on the nature of the solute particle. It don't depend on the nature of the solute particle. Next, we are having the types of colligative property. First, we are having the relative lowering in vapor pressure, then elevation in boiling point, depression in freezing point. We are having the third, and fourth one we are having the osmotic pressure. So one by one we will cover colligative property. So students, from this colligative property part, there was question in the GPAT, NIPER, as well as sometime in the drug inspector examination also. So first and most important, we are having the relative lowering in vapor pressure. First colligative property that we will discuss today, that is relative lowering in vapor pressure. So sir, why there is a down in the vapor pressure? What exactly we had done with the solute solvent? So it is basically, student, please be there na, it is most important. It is basically when a non-volatile solute is added to a solvent and the vapor pressure is decreased. What we had done, we had added non-volatile solute. Non-volatile solute we had added, and there is a decrease in the vapor pressure. Vapor pressure is decreased. So the relative lowering in vapor pressure of the solution containing the non-volatile solute is equal to the mole fraction of solute in the solution. So the relative lowering in vapor pressure of solution containing a non-volatile solute is equal to mole fraction of solute in that of solution. So here we are having the representation of the relative lowering in vapor pressure. As I told you, it is basically inversely proportional to the molecular mass. So here N2, that is the molecular mass of solute, moles of the solute, and N1 plus N2, that is the solute and solvent. So P0 and PS, that is initial vapor pressure, then the vapor pressure in the solid state. So we are having the two method that is basically used for calculating or measurement of the lowering of the vapor pressure. First, we are having the barometric method. Second, we are having the Ōswald-Walker method. Barometric method and Ōswald-Walker method, these are the two methods that we use to measure the relative lowering in vapor pressure. So this question was previously asked, I think, in GPAT 2021. And similarly, in the next year, GPAT 2022, there was also there were two questions from the colligative part only. Second, we are having the next colligative property, that is elevation in boiling point. Elevation in boiling point, that is the next colligative property we are having. Why there is a dilution in the why there is an elevation in the boiling point, sir? It occurs due to addition of the non-volatile solute in a pure solvent, and the vapor pressure of the solvent decrease. Therefore, to boil the solution, the required temperature will be greater. So it basically occurs due to addition of the non-volatile solute. The same case that we had taken for the we can say relative lowering in vapor pressure. Same case. Like here, we have also had added the non-volatile solute. So same in this case, there are addition. If the non-volatile solute is added, then elevation in boiling point is noticed. So vapor pressure of solvent get decreased. Therefore, if we want to boil the solution, the required temperature will be higher. So there is a requirement of the higher temperature. There is a requirement of the higher temperature. So there will be a rise in boiling point of the solution. There will be a little bit rise in the boiling point of the solution. So the increase in the boiling point is known as your elevation in boiling point. So that this increase in boiling point is known as elevation in boiling point. Why it has happened, sir? It happened because we are adding non-volatile solute. So non-volatile solute, sir, what is volatile? Like in the pharmacognosy, I hope you know cardamom, cinnamon, cloves, cloves. And these type of oil are our volatile oil. That is terpenoid. Non-volatile means that are unable to evaporate. So it is represented by elevation in boiling point is represented by delta TB. Kb, that is a constant that is known as your 𝙂𝙂𝙎𝙬𝙎 constant. Secondly, we can say Kb is our molar elevation constant, where m is your molality. Here m is your molality. That is a new concept. Small m is our molality. That is weight of solute, weight of solvent divided by molecular weight of solvent and your weight of the solution. So here molality, we are taking the weight of the solvent in the gram. In gram or kg, we are taking weight of the solvent. Got it? This is weight of the solute, na? And there is then weight of solvent. Weight of solvent. So weight of the solute, W2, and W1, that is the weight of solvent. Got it? Solute and solvent. Next, Kb. What exactly the Kb, sir? That is 𝙂𝙂𝙎𝙬𝙎 constant, or we can say molar elevation constant. So Kb for the water, that is 0.52 kilo Kelvin mole minus. Kb here is inversely proportional to the enthalpy of vaporization. Enthalpy of vaporization is inversely proportional. So Kb is equal to RTB square m square delta Hm and B. Delta Hm, that is the molar heat of vaporization. Next measurement we are having, that is the Lenderberg method, Beckman method, and control method. We can use just to calculate the elevation in boiling point. So these are the important points that I had taken from where there was question, and definitely there will be the question in your upcoming pharma examination. So please watch this video completely. Focus here. Your every video, the video that you are going to watch in this series, or we can say your everyday effort, will going to be count. It is not like, sir, if the examination date will schedule, then after we will plan for the revision. No, your in student life, there is no single day without the revision, without the reading. Third colligative property, we are having depression in freezing point. So when a non-volatile solid is added to the solvent, its vapor pressure decrease. Now it would become equal to that of solid solvent at lower temperature. To that of solid solvent at lower temperature. So depression in freezing point is our equal to freezing point of solvent and freezing point of solution. Means there is a decrease in the freezing point. Somehow the freezing point is higher, and now due to addition of the non-volatile solute, the freezing point get decreased. Depression in freezing point. It is having the representation like Kf is equal to Tf is equal to Kf W2 by M2 and W1. Kf for the water, that is the 1.86. This constant you have to be remember, student. There was previously the questions in the previous examination. They are asking for the triple point of water. They are asking for the boiling point of water. Maybe they will ask your cryoscopic constant of the water, that is 1.86. Maybe they can ask that is regarding the 𝙂𝙂𝙎𝙬𝙎 constant. So Kf is cryoscopic constant or molar depression constant. In the previous colligative property, that is elevation in boiling point, we had discussed Kb concept, that is 𝙂𝙂𝙎𝙬𝙎 constant or molar elevation constant. So Kf, that is having the unit Kelvin kilojoule mole minus, and Kf is inversely proportional to the delta H of fusion. And measurement method, we are having the Rost-Kaempfer and Beckman method. So you can use the trick like depression, that is depression in freezing point, rest in back. Rest in back. So you can use the trick. I am in depression, so I need to rest in back. That is the simple trick to you to remember the depression in freezing point. Here is a trick you can use. My BP is rise means elevation in boiling point due to uncontrolled land backslide. Means control land and back. Means a person BP is going to be rise because they are having the uncontrolled land on the back side. We can say next and last colligative property we are having the osmotic pressure. This is most important, student, and this is the unique or we can say somehow different from the previous four. Osmotic pressure, or we can say osmosis. First we have to know like osmosis. It is the phenomena that is a very spontaneous flow of the solvent molecule through a semi-permeable membrane from its pure solvent to the solution and from a dilute solution to the concentrated solution. So osmosis is the phenomena of what? It is a spontaneous phenomena, means it is going to be continue. It is not like that it is stopped now then again you start. Spontaneous process are those processes that remain continue. So phenomena of spontaneous flow of the solvent or molecules through what? Through a semi-permeable membrane from the pure solvent to the solution or from the dilute to the concentrated. Dilute to the concentrated, or we can say in the simple word we can say from the pure solvent side to the solute side, solution side. Means somehow there is an addition in the solution. Somehow already things are added because solute and solvent, if we are going to add solute and solvent, definitely they are going to form the solution. So the minimum external pressure applied on the solution to make its vapor pressure equal to that of solvent is known as your osmotic pressure. So there is a requirement to exert the minimum pressure on this SPM, semi-permeable membrane. Minimum external pressure applied on the solution to make vapor pressure equal to the solvent is known your osmotic pressure. Is known your osmotic pressure. So for diluting solution, osmotic pressure is proportional to the molarity of the solution at a given temperature. For dilute solution, osmotic pressure is equal to the molarity of solution at a given temperature. So osmotic pressure method is the best method of determining the molecular mass of polymer. Most important. It is most important. For dilute solution, osmotic pressure is equal to or proportional to the molarity of solution at a given temperature, and osmotic pressure method is the best method for determining the molar mass of the polymer. So here is the representation of the osmotic property, that is pi V is equal to nRT. Pi is your osmotic pressure, V is the volume, N is the number of moles, R is your gas constant, and T is the temperature. So we can represent your osmotic pressure, that is W1 RT M1 NV. That is simple, somehow looking like that your ideal gas equation, that is PV is equal to nRT. So relative pressure between osmotic pressure and vapor pressure lowering at an infinite dilution is represented by pi is equal to RT by V1 log P naught by P. So that is relative pressure between osmotic pressure and vapor pressure lowering at infinite solution, that is pi RT by V1 log P naught by P. So this is the representation of your osmotic pressure. Sir, this method, these are the methods that are used to find out, used to measure the osmotic pressure. We are having the Berkeley and Heckley method, Moraz and Fetzer method, Vries and plasmatic method, Pfeffer method, Townsend in negative pressure method. So these are the methods that we are used for the measurement of the colligative property, that is osmotic pressure. So next we are having a few questions, and basically I just you can say include 3 to 4 question only, as this is a very concise topic. The all the 4 colligative property, each and every point itself a question. So it is not like, sir, which question we have to do the practice in the colligative property. Each and every line, this is a very little or short video, around 20 minutes video I think you will get. So 20 minutes, in 20 minutes, there is one concept, maybe one question, two question definitely in your examination. So first question, a cell is bathed in a solution that has a greater osmolarity than the cytosol. And this solution is best described in which of the following way? Like a cell bath is having the higher osmolarity, greater osmolarity than the cytosol, means concentration is is higher than the cytosol. So it is describing isotonicity, no. Hypersensitivity, hypertonic, yes, we can consider. Hypertonic, no. So isotonic means somehow same osmolarity that of our cytosol. Hypotonic means osmolarity down than the cytosol. If osmolarity is greater, then this is the case relevant to the hypertonic. Next, we are having the osmotic pressure of a solution increased if when the osmotic pressure increase when temperature is decreased, no, there is no relation. When the solution concentration is decreased, no. Osmotic pressure is increased when the number of solute increase. Now, first definition of the colligative property that are depend on the nature of the solute particle. Got it? So number of solute particle n is going to be increased, then osmotic pressure is also going to be increased. Or you can like use this formula, pi v is equal to CRT. So if temperature is increased, so it means temperature is decreased means it leads to the decrease. Second case, concentration is increasing, down thing, then it is also going to be decreased. Volume is increasing, so it is going to be down also. So number of solute, or we can say osmotic property, is directly proportional to the number of solute particle. Colligative property directly proportional to the number of solute particle. If the solute particle is increased, then obvious colligative property is also increasing. Then next concept, we are having the isotonic solution. So what exactly the isotonic solution? As the name indicate, they are having the same thing, same temperature. Osmo means osmotic pressure. So they are having the same osmotic pressure. They are having the same osmotic pressure. That is your isotonic solution. Got it? So there is a little concept here also, that is Van 't Hoff factor. It is a miscellaneous, but don't have to be skip this topic. So sometime it has been noticed that the colligative property depend on the number of particle, but not but sometime particle may be association and dissociations, hence there is an abnormal result. Sometime our colligative property are giving the abnormal result. Due to this, there is an why abnormal result is there? Because the solute particle, like the particle undergoing the dissociation and association. So that we are having the Van 't Hoff factor. So in order to account for the same abnormal cause, Van 't Hoff factor we can use. What exactly Van 't Hoff factor? Van 't Hoff factor is your normal molar mass divided by observed molar mass. So normal divided by observed molar mass, that is our Van 't Hoff factor. And degree of association and dissociation can be calculated if Van 't Hoff factor is known. Degree of association and dissociation is calculated if Van 't Hoff factor is known. Got it? So I is equal to your observed colligative property divided by your calculated colligative property. That is your in another term we can explain your Van 't Hoff factor. So for dissociation, we can write 1 minus alpha n alpha. Then dissociation we can write it like 1 minus alpha plus n alpha. For association, we can write 1 plus alpha n minus 1, and then again we can classify for the nf. So this is about your concept of the colligative property, in which we had discussed about the 4 colligative property: depression in freezing point, elevation in boiling point, relatively lowering in vapor pressure, and osmotic pressure. We had just done with the MCQ part, and then a miscellaneous concept, Van 't Hoff factor is there. So student, I hope you had enjoyed this session, and please be there in each and every sessions. Have a good day. Always GDC is for you. We are here to provide the best and best content. Please watch each and every video. If you are liking this video, try to subscribe our YouTube channel. Write in the comment box. Your each and every appreciating comment will boost our energy also. And I will come back with the next video, next part of the colligative property. Thank you so much, everyone, and all the best.